The most significant piece of evidence that we have in this entire ancient astronaut puzzle is Puma Punku in the highland of Bolivia.
For decades, the H-blocks of Puma Punku have puzzled researchers and visitors alike. With their razor-thin joints and perfectly geometric shapes, these stones seem almost impossible to explain. Their precision is so extreme that many have suggested they could only have been made using lost or forgotten technologies. According to the official explanation, these massive blocks were carved by hand and transported across the Bolivian highlands nearly 1,500 years ago. But discoveries made in laboratory tests in 2025 have introduced new evidence that challenges this long-held belief. Located high in the heart of Bolivia, Puma Punku continues to resist simple answers. Its most iconic elements, the H-shaped blocks made of andesite, are both impressive and deeply confusing. The surfaces are cut with such consistency and accuracy that they rival the standards of modern engineering. Even more astonishing are the joints between the stones. They fit together so tightly that, according to local tradition, not even a razor blade could slide between them. This idea, passed down through generations, may sound like legend, but the craftsmanship seen at Puma Punku suggests there may be more truth to it than we once believed. Archaeologists and engineers have stood before these massive blocks for generations, carefully examining the joints and finding them astonishingly uniform. Even after centuries of exposure to harsh weather and frequent seismic activity, the precision of the stonework remains remarkably intact. But the story of Puma Punku's perfection doesn't end with ancient craftsmanship. The site's current state of ruin tells a very different story, one shaped by a much less respectful era. In the late 1800s, as railways pushed their way across Bolivia, dynamite crews and stone scavengers descended on the ancient complex. Huge stone blocks were knocked over, broken apart, and hauled away to be used as ballast for railway lines and materials for bridges. Historical accounts from that time describe scenes of destruction and disorder, marking a period when Puma Punku suffered some of its greatest damage. Blasting shattered, carefully carved stones. Perfectly fitted blocks were forced apart and stripped of their value, while entire sections of the platform were dismantled with no concern for their original design. The H-blocks, once locked into a single, unified structure, now lie scattered across the site, their original purpose buried beneath decades of damage and neglect. And yet, even in this broken state, the stones continue to raise profound questions. How were builders able to produce such sharp right angles and perfectly uniform slots using only simple tools like hammerstones and bronze chisels? Or so the official explanation claims. Some look to Aymara oral tradition, which speaks of stones that once flowed like water, soft enough to be shaped by hand before hardening into stone. Passed down through generations, this story hints at a process or technology that may have been lost to time. Others argue these tales are symbolic, born from awe at craftsmanship so advanced it defies easy explanation. The debate surrounding Puma Punku is not just about tools or construction methods, it is about the limits of human ingenuity itself. The visual evidence is difficult to ignore, puzzle-like joints, untouched geometric patterns, and the absence of clear tool marks on many surfaces. Together, they force skeptics and believers alike to confront the same question. What knowledge did the builders possess that allowed them to shape stone with such apparent ease? For now, the answer remains out of reach, hidden beneath the scars of history and the silence of the stones. Puma Punku stands on a windswept plain just west of Lake Titicaca, linked to the ancient city of Tiwanaku by both geography and history. Its name, meaning Gate of the Puma in Aymara, echoes the animal's symbolic power, suggesting a guardian standing at the threshold of a monumental past. To understand the mystery of its stonework, the site must first be placed in time. Decades of excavation and radiocarbon dating point to Puma Punku's first major phase of construction between AD 536 and 600. This timeline does not come from the stones themselves, but from organic remains, charcoal, plant fibers, and bone found deep within the fill beneath the platform. Analyzed in laboratories around the world, these samples form the statistical foundation of Puma Punku's chronology. As Bayesian modeling techniques have advanced, archaeologists have incorporated hundreds of radiocarbon dates from the Tiwanaku region into increasingly precise timelines. The result reveals an era of intense construction throughout the first millennium AD, with Puma Punku emerging during Tiwanaku's earliest surge of monumental building. In recent years, the timeline of Puma Punku has become even clearer. In 2023, a large collection of radiocarbon dates from the region made it possible to create highly precise chronological models, narrowing the uncertainty around each phase of construction. While the stone blocks visible today cannot be directly dated, the material found beneath them tells a consistent and convincing story. By the late 6th century, Puma Punku was already emerging as a ceremonial platform, its massive stones placed atop carefully prepared layers of earth and fill. The evidence leaves little room for doubt about its early development. At the same time, the wider Tiwanaku complex continues to reveal unexpected discoveries. In 2024, researchers announced the discovery of the Palaspata Temple. Although full details have yet to be published, the find has reignited efforts to better understand the order and scale of ceremonial building across the region. For now, the Palaspata discovery stands as a powerful reminder of how much of the ancient Andean world still lies buried beneath the soil, waiting to be uncovered. The story of Puma Punku's origins cannot be separated from this ongoing investigation. It is a story shaped not only by legend, but by a growing body of scientific evidence. With every new radiocarbon date and each carefully studied soil layer, we move closer to understanding the world in which these remarkable stones were first placed. To understand how Puma Punku was built, we must start with the stones themselves. The famous H-shaped blocks carved from dense andesite were never meant to be purely decorative. They were structural elements, carefully engineered to lock together in 3 dimensions. Each block is shaped with a precise system of grooves, notches, and protruding tabs that allow it to interlock with surrounding stones like pieces of a complex puzzle. This modular design appears again and again across the site, creating walls and platforms that remain stable against both gravity and frequent seismic activity. The geometry serves a purpose beyond appearance. Perfect right angles are preserved across entire block faces, while parallel slots are cut to uniform depths and widths, ensuring that each stone fits seamlessly with the next. Beneath the visible surface, the builders reinforced the structure with a foundation system anchored directly into the bedrock. Massive sandstone slabs, some weighing more than 100 tons, were placed into carefully leveled trenches. In several areas, the foundation stones were secured using tongue and groove joints, a method that helped distribute weight evenly and prevent sideways movement. This approach was especially effective in the earthquake-prone Altiplano, where unstable ground can easily bring down less resilient structures. Another striking feature of Puma Punku is the use of metal clamps. Archaeologists have discovered evidence of eye-shaped bronze staples set into the joints between stone blocks. These clamps, made from a copper tin alloy, were poured into precisely carved channels and then hammered flat, locking neighboring stones together. Metallurgical studies show traces of arsenic in the metal, a hallmark of pre-Columbian Andean bronze technology. The presence of these clamps points to a deliberate strategy to strengthen the stonework, helping prevent the blocks from separating during earthquakes or periods of heavy rainfall. Throughout Puma Punku, careful load distribution is a consistent design principle. The immense weight of each block is directed not only downward, but also outward through a network of interlocking shapes. This spreads stress across many contact points, reducing pressure on any single joint. Because of this engineering approach, much of the platform has endured for centuries despite earthquakes, flooding, and human interference. Recent digital reconstructions using high-resolution photogrammetry and 3D modeling have confirmed the soundness of the original design. These studies show that the modular H-blocks, keyed foundations, and metal clamps worked together to create a structure that was both strong and flexible, an impressive achievement made with simple tools and a deep understanding of materials. In recent years, digital archaeology has provided a new way to study Puma Punku's scattered stones. The challenge is significant. Centuries of damage, looting, and natural upheaval have left the H-blocks and massive stones out of place, turning their original arrangement into a puzzle with missing pieces. Even so, technology is beginning to close the gap between theory and evidence. In 2018, a research team from UC Berkeley attempted to reconstruct the monument, not with stone, but at a smaller scale. Using high-resolution scans of every documented block, they created a complete set of 3D printed models, each reproduced with millimeter-level precision. The reconstruction process turned out to be as much a forensic investigation as an engineering exercise. Early attempts to reassemble the monument quickly revealed the problems caused by outdated site maps. Blocks refused to line up, and the platform's distinctive T-shaped layout seemed impossible to achieve. It was only after researchers carefully recatalogued the stones and corrected the orientation of several H-blocks that the structure began to make sense. Once aligned properly, the model started to take shape. With its interlocking stones and windowed gateways, the reconstruction showed that the original builders had followed a precise, repeatable system. Even at a reduced scale, the miniature blocks locked together cleanly, proving that the design logic remained sound. But the work didn't stop with physical models. A major breakthrough came during the 2024 to 2025 IDIA Labs campaign, which used drone-based photogrammetry and terrestrial LiDAR to record the ruins in extraordinary detail. The result was a highly accurate digital twin of Puma Punku, precise to within just a few millimeters. This virtual model allowed researchers to test ideas that would be impossible to attempt on the actual site. Using advanced mesh-matching techniques, the team digitally reassembled the monument, aligning block surfaces with average errors between 2 and 8 millimeters. This level of accuracy confirmed that the H-blocks and other elements were designed to fit together in modular patterns, supporting the idea of a carefully planned and standardized construction rather than an improvised one. Gravity-based simulations within the software showed that when allowed to settle naturally, the virtual blocks locked into place and remained stable, mirroring the real-world durability of the original platform. These digital reconstructions have done more than recreate lost architecture. They have served as a testing ground for engineering principles, eliminating unlikely layouts and strengthening the case for the T-shaped platform with its balanced, symmetrical gateways. Machine learning analysis of the models has also revealed underlying symmetries and proportional systems, pointing to a highly sophisticated spatial design. Still, while the modular fit and structural logic are now well established, one major question remains unanswered. How were the blocks actually made? Whether they were carved, cast, or shaped using methods still unknown has yet to be resolved. Full seismic and load-bearing simulations are ongoing, and as of 2025, no peer-reviewed results have been published. What is now undeniable is that the builders of Puma Punku worked with a level of precision that rivals modern masonry. For the first time, the site's geometry can be measured, tested, and debated in ways that were never previously possible. Although the stones are scattered across the landscape, their secrets are beginning to come together in the digital world. Red sandstone forms the foundation of Puma Punku's massive platform, with some blocks weighing up to 130 tons. For decades, the origin of these stones puzzled researchers. No nearby quarries show marks that match the size or finish of the blocks, and no fully convincing explanation has ever been offered for how such enormous pieces were transported across the Altiplano. Recent laboratory studies have shifted the discussion in a new direction. Under scanning electron microscopes, thin samples of the sandstone reveal a composition that does not match any known natural rock sources around Lake Titicaca. One of the most striking findings is the presence of sodium carbonate or natron in concentrations that do not occur naturally in the local geology. This chemical signature, combined with the presence of amorphous binding material, suggests that the blocks may not be natural stone at all. Instead, some researchers propose they were artificially created. The theory points to an ancient form of geopolymer technology, possibly based on ferroaluminosilicate chemistry. By mixing local sand, volcanic ash, natron, and water, ancient builders could have produced a moldable paste. This material could be poured into forms and left to harden, eventually becoming stone. When modern laboratory replicas made using this method are examined under scanning electron microscopes and X-ray diffraction, they display the same density, durability, and sodium signatures found in the stones at Puma Punku. The amorphous binder phases, clear evidence of chemical reactions, are nearly identical. Taken together, these findings point toward an artificial manufacturing process rather than natural stone formed slowly through sedimentation over thousands of years. Sodium carbonate plays a key role in this theory. It is well known from ancient Egyptian mortars, but it is extremely rare in the Andes. Natron acts as a flux, lowering the temperature required for geopolymerization. Its presence in the sandstone at Puma Punku, and its absence in nearby natural deposits, suggests that the builders either imported it or produced it themselves. If true, this would have allowed them to cast stone blocks of virtually any size, avoiding the enormous challenge of quarrying and transporting massive slabs. The casting hypothesis also helps explain several puzzling features: the uniform surfaces of the blocks, the lack of visible tool marks, and the razor-sharp joints between stones. Unlike natural sandstone, which tends to fracture unevenly, these blocks display clean edges and precise fits, as though they were formed in molds. Support for this idea grew with the first published discoveries of binding material seen under scanning electron microscopes in the early 2000s. Since then, laboratory-made geopolymer stones activated with sodium have closely matched both the physical strength and microscopic structure of the blocks at Puma Punku. Skeptics point out that no ancient molds have yet been found and suggest that the natron could have arrived through trade or even later contamination. Even so, the chemical and structural evidence remains persuasive. For many researchers, the sandstone analysis has become a key pillar in the argument that the builders of Puma Punku may have possessed a sophisticated technology that has since been lost to time. The next mystery centers on Puma Punku's most puzzling stones, the andesite H-blocks. In 2019, laboratory tests on these blocks sent shockwaves through the archaeological community. Using scanning electron microscopy, researchers identified a distinct nitrogen peak at 0.8 keV in the energy dispersive X-ray spectra of the andesite. When paired with the presence of carbon, this finding pointed to organic compounds, something highly unusual in volcanic rock, which forms at temperatures that should eliminate any organic material. The results suggested the possibility of an organomineral binder, a mixture in which plant extracts or animal byproducts were combined with volcanic tuff and water to create a moldable, cast-like material. Dr. Joseph Davidovits, founder of the Geopolymer Institute, has long supported this interpretation. Thin section analyses from his team show micropitting and a consistent granular texture that do not appear in andesite from nearby quarries. Control samples from natural sources show no trace of organic signatures. Laboratory replication experiments using carboxylic acids, guano, and locally sourced clays produced stone samples with microstructures and mechanical strength strikingly similar to the ancient H-blocks. These results strengthened the argument that the stones may have been chemically engineered rather than simply carved. Still, the debate is far from settled. Critics argue that the nitrogen signal could be the result of surface contamination or instrument error, and they caution that findings from a single laboratory are not enough to overturn decades of established geological understanding without independent verification. To move beyond speculation, researchers have developed a tiered framework for evaluating the evidence. The first level focuses on what can be seen: extremely tight joints, the absence of obvious tool marks, and precise geometric forms. The second level examines the stones at a microscopic and chemical scale, using techniques such as scanning electron microscopy, energy dispersive X-ray spectroscopy, and petrographic thin section analysis. The highest level of evidence requires blind, multi-laboratory verification. This includes radiocarbon dating of any organic material found within the stones. Only if multiple independent laboratories detect the same organic signatures, and if the resulting dates align with the established Tiwanaku timeline, can the casting hypothesis be considered credible. That process is now underway. Microcore samples taken from at least 8 H blocks will be divided and sent to independent laboratories under coded labels. Each lab will conduct SEM, EDS, and organic compound analyses without knowing the sample's origin. If organic material is detected, it will be subjected to acid-base acid pretreatment and accelerator mass spectrometry for radiocarbon dating. All findings, whether they support or reject the hypothesis, will be published in full, including raw data and documented chains of custody. If an organo-mineral binder is confirmed and its age matches the construction window of AD 536 to 600, Puma Punku would represent the earliest known example of large-scale geopolymer technology in the Americas. If not, the mystery remains open. Either way, the H blocks stand as a rare case where speculation gives way to testable science. Radiocarbon dating of mound fill and ceramics shows that Puma Punku's H blocks were first set in place between AD 536 and 600. More than 150 years after railway construction scattered many of the stones, the site remains a puzzle defined by extraordinary precision. Recent laboratory studies have detected nitrogen and carbon within the andesite blocks, lending support to the organo-mineral geopolymer theory. However, independently verified, peer-reviewed radiocarbon dates for these organics have not yet been published. Digital reconstructions by teams from UC Berkeley and IDIA labs have confirmed that many of the blocks were designed to interlock as part of a unified system. Still, questions remain about the exact techniques used to achieve such flawless joints. As of 2025, mainstream archaeology and proponents of the casting hypothesis continue to debate the evidence. New discoveries, including the Palisparta Temple, and ongoing research across the region show that Andean history is still being rewritten. For now, the true origins of Puma Punku's H blocks remain unresolved, but the growing body of evidence points to a remarkable level of ancient ingenuity and a mystery that modern science has only begun to explore.